Okay. Hello, YouTube. I am live. Let's get functional. I am learning, or perhaps relearning, my way through the Boot.dev course about functional programming in Python. And so, I have the Boot.dev website over here. I also have a terminal over here where I could take notes or echo things to the screen or just have a let's get functional message. I'm also listening to some jazz in the background that I'm not broadcasting. So if I start head bobbing a little bit, that'll be why. With that said, let's get into pure functions and gain some sweet dopamine through experience points. Also, I'm going to use on the platform a buy potion and activate. Okay, pure functions. If you take nothing else away from this course, please take this. Pure functions are fantastic. They have two properties. They always return the same value given the same arguments. Running them causes no side effects. In short, pure functions don't do anything that exists. Let me start that again. In short, pure functions don't do anything with anything that exists outside of their scope. Now we get an example of a pure function. Define find max of nums. Max val equals float at minus infinity. For num in nums, if max val less than num, max val equal num, return max val. Let's examine this to establish what they claimed. Max val was defined in scope. We use that. Nums got fed in. And the only thing we do with nums is iterate over its values, so we don't do anything to it, really. Can you call a read doing something to something? I think that's getting too deep for this. Num we defined here and only use in the for loop. So yes, in this case, we don't do anything with anything that's out of scope. Example of an impure function. Instead of returning a value, this function modifies a global variable. We have global max is float of minus infinity. Define find to max of nums. It looks like a similar function, but with an important difference that we have global max, and we compare to that in the maximum value calculation. Assignment. There's a bug in convert file format function. Right now, it relies on data outside its own scope. These global values can be changed by other parts of the code, so they are not guaranteed to be the same every time convert file format is called. Fix the bug by making convert file format a pure function. It should only depend on data that is scoped inside of the function. Don't change the signature of convert file format. So we're not allowed to feed in these valid extensions and valid conversions as arguments. Let's look at the file. Let's look at the function they've given us. Define convert file format, file name, target format. Current format is file name dot split on a period -1, so the last. If current format in valid extensions and target format in valid conversions from current format, interesting, then we return file name dot replace of current format with target format, else we return none. I think what they want us to do is lift these definitions out of the global scope of the script and simply drop them inside of the function, but with some attention to indentation. And I'm guessing the tests will try to do something. I wonder how they tested this. Let's run it. Looks like it got what expected, so now I'll submit. All passed. And how does it check into it? Import main as main underscore. That's an interesting trick. I wonder why they needed to do that. Run cases and then some more submit cases. Define mutate globals. Okay, this is where they throw a wrench in. In here, valid extensions would have been defined in main as all of these things. 1, 2, 3, 4, 5, 6 of them. But in here, 1, 2, 3, 4, we have 5. So one of them was missing. I'm not sure which. And then I guess we're going to call main below. Main.convert file formats, input 1, input 2. So if valid extensions had been defined here, it would have been overwritten, and some of the tests would not have come out the same way. Cool. Let's move on to lesson 2. I did submit it, right? Yeah, I did. Pure functions have a lot of benefits. Whenever possible, good developers try to use pure functions instead of impure functions. Remember, pure functions return the same result if given the same arguments. They are deterministic. Do not change the external state of the program. The pure functions do not change the external state of the program. For example, they do not change any variables outside of their scope. They do not perform any I/O operations like reading from disk, accessing the internet, or writing to the console. These properties result in pure functions being easier to test, debug, and think about. Refer to the following examples and answer the questions. Example 1. Multiply by 2 of numbers. Products equals empty list. For num in nums, products dot append nums times 2 dot append num times 2. Return products. Okay? And this is asking about example 1, so we can go ahead and try to answer that. Options are pure or impure because it is non-deterministic, or impure because it affects state in an outer scope. It only affects state in its own scope. Note that we are mutating state of properties, but that's only inside of this scope. So it's not that. Non-deterministic. Multiplication is deterministic, so it's pure. Example 2. Balance equals 100. This is looking like it's not going to be pure. Example 2. Balance equals 100. Cars equals empty list. Define by car of new car. Global balance. Cars.append new car. Balance minus equals 69. Why did they need to call global on balance but not on cars? I know why. That might be worth digging into. I'm just gonna toss it into an example for now. Vim example.py. Maybe examine later. Oh, before I write, maybe examine to talk about why the global keyword is only needed on balance. Okay. So we've got that in case I want to look at it later. Example 2 is clearly impure because it affects state in an outer scope. Gained XP, nice. Example 3. Example 3 is import random, define roll die num sides random.randint from 1 to num signs. It is non-deterministic. That's a little bit of a... I mean, there's some depth to that, because if we wanted to, we could set a seed, and then it would be deterministic. But we haven't set the seed, so that's going to come in from the computer hardware somewhere, probably. So it's non-deterministic. I'm thinking about interesting ways to include random, but then process the results in a way that the randomness doesn't affect the output. So like, take away the randomness and make it deterministic again. It's kind of interesting. Okay, moving on. Level 5, reference versus value. When you pass a value into a function as an argument, one of two things can happen. It is passed by reference. The function has access to the original value and can change it. It is passed by value. The function only has access to a copy. Changes to the copy within the function don't affect the original. There is a bit more nuance, but this explanation mostly works. These types are passed by reference, lists, dictionaries, and sets. These types are passed by value, integers, floats, strings, booleans, and tuples. Most collection types are passed by reference, except for tuples, and most primitive types are passed by value. Example of pass by reference mutable. Define modify list of inner list append 4. The original outer list is updated because inner list is a reference to the original. Outer list equal 1, 2, 3. Modify list of outer list equals 1, 2, 3, 4. Example of pass by value immutable. Define attempt to modify. Inner num plus equals 1. The original outer num is not updated because inner num is a copy of the original. So if outer num equals 1, and we attempt to modify and we pass in outer num, then yes, inner num will receive the value of 1. It will increment it by 1 and save that to inner num, but outer num will stay the same. Assignment. We have a way for doc-to-doc users to set their supported formats in their settings. In memory, we store these settings as a simple dictionary. Settings equals docx true, pdf true, text false. Unfortunately, there is a bug in our code. Oh no. When a new format is added or removed, it not only updates the new dictionary, but it changes the defaults themselves. That's not good. We want to create a new dictionary with the updates, not change the original. Fix the bug by making add format and remove format pure functions that don't mutate their inputs. Let's see how this is being done. Default formats and new format. Yeah, I see the problem. Default formats is getting something changed. And my immediate thought is to do a .copy operation, but I wonder about deep copy. Let's see what the tip says. Simply assigning a new variable to an existing dictionary doesn't copy that dictionary. It points to the same dictionary. Instead, use the .copy method to create a new copy of a dictionary. Okay, we'll do it that way. Let's call it new formats, plural, equal default formats.copy, and we'll return the new formats and also modify the new formats. Similar idea here. Remove format. Okay, same idea. Old formats equals default formats.copy. And we put that in place here and here. And let's run it to test. Looks good. Logic makes sense to me, so I'm going to go ahead and submit. Gained plus 160 XP. Nice. Okay, pass by reference impurity. Because certain types in Python are passed by reference, we can mutate values that we didn't intend to. This is a form of function impurity. Remember, a pure function should have no side effects. It shouldn't modify anything outside of its scope, including its inputs. It should return new copies of inputs instead of changing them. Pure function. Define remove format, default formats, old format. New formats equals default formats.copy. New formats at old format equals false. Return new formats. Now an impure function. Define remove format, default formats, and old format. Default formats of old format equal false. Return default formats. Why do we care? One of the biggest differences between good and great developers is how often they incorporate pure functions into their code. Pure functions are easier to read, easier to reason about, easier to test, and easier to combine. Even if you're working in an imperative language like Python, you can and should write pure functions whenever reasonable. There's nothing worse than trying to debug a program where the order of function calls needs to be just right because they all read and modify the same global variable. Question: a pure function can mutate its local variables? Sure. Mutate its inputs? No. Mutate global variables? No. Call functions that mutate global variables? No. Okay. 7. Pure functions should be avoided at all costs, execute faster, or are easier to debug, read, and test. That's the one. Hey, XKCD, nice. Input and output. I'm glad you're including more comments in your code, but it would be nice if they were comments about your code, or at least a bit less obscenity filled. Look, they say to write what you know. Okay. All the functions you've written take everything passed to them and return it unchanged with the comment, no, you deal with this. It's a functional programming thing, avoiding side effects. You avoid all effects. Only way to be sure. Okay, good one. The term I/O stands for input-output. In the context of writing programs, I/O refers to anything in our code that interacts with the outside world. Outside world just means anything that's not stored in our application's memory, like variables. Examples of I/O: reading from or writing to a file on the hard drive, accessing the internet, reading from or writing to a database, even simply printing to the console is considered I/O. Yeah, my monitor is a device. All I/O is a form of side effect. Assignment: in Doc2Doc, we frequently need to change the casing of some text. For example, title case. Every day, once a day gives you a present. Wait. Every day, once a day, give yourself a present. That makes more sense. Lowercase. Every day, once a day, give yourself a present. Uppercase. Shouting. Every day, once a day, give yourself a present. There is an issue in the convert case function. Our test suite can't test its behavior because it's printing to the console. Ooh, a side effect. Instead of returning a variable. Fix the function so that it returns the correct value instead of printing it. Okay, where are we? We raise a value error in some case. Here's where we're printing. We just move that to a return. Same thing here. I'm tempted to drop this into Vim for more stylish editing and then bring it back here, but yeah, we'll just do it this way. That looks good. Okay, submit. Should I/O? A program that doesn't do any I/O is pretty useless. What's the point of computing something if you can't see the results? I'm a functional programmer. What's that mean? It means he's scared of side effects. I am not. Ooh, print. Stop it, you're scaring him. Uh-huh. Yes. In functional, I/O is viewed as dirty but necessary. We know we can't eliminate I/O from our code, so we just contain it as much as possible. There should be a clear place in your project that does nasty I/O stuff, and the rest of your code can be pure. For example, a Python program might read a file from the hard drive as the program starts, run a bunch of pure functions to analyze the data, write the results of the analysis to a file on the hard drive at the end. And we've got some nice color coding here with count lines, spell check, and reformat being the pure parts. I/O should be blank in functional programming. Strewn all throughout, only used when Simon Peyton-Jones isn't looking, limited to specific parts of the code base, or avoided completely. We need to limit it, but still use it. 10. From the user's perspective, a program with no I/O is fast. Well, not necessarily. Does nothing. I think so. Can only read from an external database. Not true. Can only print to the console. Does nothing. 11. No-op. A no-op is an operation that does nothing. If a function doesn't return anything, it's probably impure. If it doesn't return anything, the only reason for it to exist is to perform a side effect. Example no-op. This function performs a useless computation because it doesn't return anything or perform a side effect. It's a no-op. Def square x, x times x, but no return. Example side effect. This function performs a side effect. It changes the value of the y variable that is outside of its scope. It's impure. Y equals 5. Def add to y of x, global y plus equals x, add to y of 3, now y equals 8. The global keyword just tells Python to allow modification of the outer scoped y variable. Print. Even the print function technically has an impure side effect. It doesn't return anything, but it does print text to the console, which is a form of I/O. Oops, sorry. Bumped the mic there. Assignment. Fix the remove emphasis function by making it pure. Here we have global doc. Remove emphasis takes a document with any number of lines and removes any number of star characters. Excuse me. Removes any number of star characters that are at the start or end of a word. In case you need it, here's a primer on emphasis in Markdown. Markdownguide.org. For example, this, I love Markdown. I really love Markdown. I really, really love Markdown. Should become, I love Markdown. I really love Markdown. I really, really love Markdown. The problem is that remove emphasis is currently impure. It modifies a global variable called doc. Now, why would it do that? It should instead accept a document as an argument and return a new document with emphasis removed. Once you've purified remove emphasis, you can also delete the global doc variable. You mean here or here? Probably both. These functions in this assignment use some Python built-in types that are definitely worth knowing, including string.split, string.strip, map, and join. Okay, we feed in doc. And we can use the new variable name. That's not a problem. We return doc, delete global doc, and delete definition there. See if this works. Should. Yeah, looks good. Submit. 12, memoization. At its core, memoization is just caching, storing a copy of the result of a computation so that we don't have to compute it again in the future. For example, take this simple function, define add xy, return x plus y. A call to add 57 will always evaluate to 12. So if you think about it, once we know that add 57 can be replaced by 12, we can just store the value 12 somewhere in memory so that we don't have to do the addition operation again in the future. Then if we need to add 5 and 7 again, we can look up the value 12 instead of doing a potentially expensive CPU operation. The slower and more complex the function, the more memoization can help speed things up. It's pronounced memoization, not memorization. Oh. This confused me for quite a while in college. I thought my professor just didn't speak goodly. Okay, Lane. Assignment. Counting the words in a document can be slow, so we want to memoize it. Complete the word count memo function. It takes 2 inputs. Side note, I feel like memoization is going to require side effects, but let's keep going. It takes 2 inputs, a document string, a memos dictionary. The keys are full document strings. Yeah, you can do that, sure. And the values are the word count of the document. It should return 2 values. The word count of the given document, an updated memos dictionary. Oh, we're returning the updated memos, okay. Here, this extra file. Create a copy of the memos dictionary. What should I call it? Memos 2, memos underscore, local memos. We'll do local memos. If the document is in the memos directory, just return the associated word count and the memos copy. No need to recompute the word count. I guess I might as well compare it against local memos. If document in local memos return, so we're expecting 2 return values, it seems. So we'll write it as a tuple. Return the associated word count, which is in local memos at key document, and the memos copy. No need to recalculate the word count. Otherwise, use the provided word count function. Return, I think it should be word count, to count the words in the given document. Except, this is not quite going to work. Store the word count in the memos copy. Oh, it didn't even say return here. I just hallucinated that. Otherwise, use the provided word count function to count the words in the given document. Let's call it count equals word count of that. And we update local memos at local memos at key document equals to count, so we can use it going forward. Return the word count and the updated memos copy. I will return the count variable that we have here and not look it up in the dictionary again, though that is a cheap operation. Return count, comma, local memos. Let's run that. 2 passed, 0 failed, 2 skipped. Very good. Let's submit that. Yes. Referential transparency. Pure functions are always referentially transparent. Maybe they're going to discuss whether that memoization thing we just did is... Well, let's see what they say. Referential transparency. Baildung.com. Interesting. Referential transparency is a fancy way of saying that a function call can be replaced by its would-be return value because it's the same every time. Referentially transparent functions can be safely memoized. For example, add23 can be smartly replaced by the value 5. The great thing about pure functions is that they can always be safely memoized. Impure functions can't be because they might do something in addition to returning a static value, or they might return different values given the same arguments. Should I always memorize? No. Memoization is a trade-off between memory and speed. If your function is fast to execute, it's probably not worth memoizing because the amount of RAM, memory, your program will need to store the results will go way up. It's also a bunch of extra code to write, so you should only do it if you have a good reason to. Which expression is not referentially transparent as the integer 5? Referential transparency is a fancy way of saying that a function call can be replaced by its would-be return value because it's the same every time. Is that the same thing as saying deterministic? Maybe not. Anyway, which expressions is not referentially transparent to the integer 5? We've already been given add23 as an example. Expression 5 already is the integer 5, so that's maybe a trick question. 3 plus 3 minus 1. Well, this one is going to be a string 2, 3. So it does not give us the integer 5, so that must be the answer they're looking for. Memoization trades blank for better blank. Trades memory usage for better speed. Yep. Wonder if there's you earned a sharpshooter chest. Neat. Open chest. Gems and seer stones. Nice. I wonder if there's got to be a way, but I was going to say, I wonder if there's a way to write a memoization that both uses memory and slows down speed. There's probably a way, if you really want to. 15. Pure functions practice. Doc-to-doc is customizable. New commands can be configured to use whichever function suits the user. However, the new commands are causing bugs in other parts of the application by mutating global values and other unintended side effects. Assignment. Fix the issues to make the functions pure. 1. Add custom command is mutating an input. Add custom command has commands as an input. We'll dismiss that for now. The simplest way to do this will be to say that commands equals commands.copy. So we create a copy of commands and then store it to, in this case, to a new variable named commands. Or is it the same variable with a new value? Question for the philosophers. To add format is mutating an input. Same things, we append. So here formats equals formats.copy. Save document is mutating an input. Change that. Same idea. Docs equal docs a copy. Oh, we have a chatter. Asks, do you work as a developer? Not right now, but I have done. Oh, I didn't finish this. Right. Also, let me adjust my off-stream view from top chat to live chat because live chat makes more sense to me. Adding limerick has a side effect, printing the standard out, and no return value. That's a simple thing to change. Return line plus double new line. Now let's run it. All passed. Let's submit. Chapter 3, level 16, pure functions practice. Okay, we'll do some more practice. Good. Date times are infamously a pain in the neck for programming. The least of the list of problems are the order of the year, month, and day of a calendar date. Some countries use day, month, year format. Others use year, month, day format. Some insane countries, I feel called out. Some insane countries use month, day, year because they want everyone else to be miserable. Personally, I often use year, month, day because it makes sense to me and because it sorts it in time if you just sort it by the characters. Anyway, fix the sort dates function. It should take as input a list of dates in month, day, year. Sadness. Okay, takes month, day, year and returns a list of the dates sorted in ascending order. An input a list of dates in month, day, year, but what is it the names or is it numbers? Let's just print and let's just side effects galore. Be afraid. I'm gonna do run here and it's gonna print the dates so I can see what they look like. So I'm guessing it's just numbers, but now we'll see. Yes, it is numbers. Oh, a chatter asks, which field of development have you worked in? I've worked as a data engineer. Where was I? Conveniently, the strings are zero padded, which means I don't have to convert them to I don't have to parse integers. I can just sort them as strings, and they will come out in order. Tanner says, okay, then you must have been using SQL mostly. I used a lot of SQL, but also quite a bit of Python. One passed. Why did one pass? That's a little funny. Anyway, I'm going to say that month, day, year is equal to dates dot split on the string dash. Yeah, that'll do. Returns a list of the dates sorted in ascending order. Oh, wait. Does it want them? It probably wants me to return them in the original format. Let's see what the tip says. The built-in sorted function might work better here than the sort list method. Create a function to transform the dates to make them easier to compare with the sorted function. Pay attention to the expected date order. It is ordered by, is it ordered? Pay attention to the expected date order. Let's see the expected date. Expected 12/25. That's month, day, year. The sorted function accepts a second optional parameter. This parameter is a function that will be called on each iteration. On each iteration? I'm not sure what that means, so I'm going to check the documentation out for sorted. That will take me to docs.python.org. Oh, they're talking about the key. Yes. That's... I see why... No, I don't see why sorted would be useful. Because if we... I am gonna use key. I'm not gonna use tuple unpacking here because it's not actually necessary. I'm gonna use a key equal with a lambda function from t, where t is a tuple, to a new tuple, which takes year as the most significant, and year is in the 0, 1, 2 position. That's here. Month is the next most significant, and it's in the 0 position. Day is the least significant, and it's in the index 1 position. Unless they don't want me to mutate dates. That might be part of this. Let's just run it here. Okay, what mistake did I make? Oh, did I reverse it? The input includes a 2024. The expected has 2024 at the end. Oh. Huh. Let me look at what it output. 1/1/23, 1/15/23, 4/10/23, 7/21/23, 10/31/23, 12/25/2022. Month, day, year. Oh, we have a chatter. J. Jonas asks, hello, sir, are you teaching Python or just creating a project? Yeah, I'm mostly teaching, also a little bit learning for myself. I'm doing a lesson on Boot.dev. The lesson states, daytimes are infamously a pain in the neck for programming. And in fact, I'm having a bit of a pain here because I'm not reasoning correctly about the way the date is presented. '23, '23, '24, '23, '22. That doesn't make any sense to me. Why did it do that? From 3 to 4 to 3 to 2? Ah, yeah. This isn't a great use case for a Lambda function. Because I would have to write t.split multiple times. Let's just define a sort key of that takes a date, return date.split on the, yeah, I forgot the split. Let's call it date list. Use a name that tells something about the type that it is. And then we create our tuple with date list 2, not 02, date list 2, typos, come on, date list 2, comma, date list 1, comma, date list, no, date list 0, comma, date list 1. This, now that I didn't need to delete that. This splits the dates up by the dashes, creates a tuple with the string representation of the numbers, ordered in a way from year to month to day. And now we can sort it based on the sort key, except I have to rearrange things so that it has access to the definition of my nice sort key function. I might have to reverse. Yeah. Now it should work. Did I mean reverse? I think I did. Okay, don't reverse. Yes, there we go. Good. Wait. Sort key, return dates. Oh yeah, because I switched them. Whew, I got a little scared there. And a little confused. Chapter 4, recursion. I like recursion. Okay. Recursion is a famously tricky concept to grasp, but it's honestly quite simple. Don't let it intimidate you. A recursive function is just a function that calls itself. Recursion is the process of defining something in terms of itself. In order to understand recursion, one must first understand recursion. Example of recursion. If you thought loops were the only way to iterate over a list, you were wrong. Recursion is fundamental to functional programming because it's how we iterate over lists while avoiding stateful loops. Take a look at this function that sums the numbers in a list. define sum nums of nums. If length of nums is 0, return 0. Return nums at position 0, index 0, plus function sum nums, taking nums array list. This is Python, it's a list. Nums list from position 1 to the end. Print sum nums 1, 2, 3, 4, 5, 15. Don't break your brain on the example above. Let's break it down step by step. Solve a small problem. Our goal is to sum all the numbers in a list, but we're not allowed to loop. So we start by solving the smallest possible problem, summing the first number in the list with the rest of the list. Return number 0 plus sum numbers 1 to the rest. Recurse. So what actually happens when we call sum nums 1 to all? Well, we're just calling sum nums with a smaller list. In the first call, the nums list was 1, 2, 3, 4, 5, but in the next call, it's just 2, 3, 4, 5. We just keep calling sum nums with smaller and smaller lists. The base case. So what happens when we get to the end? Sum nums 1 to all is called, but nums 1 to all is an empty list because we ran out of numbers. Convenient that slice notation is able to return an empty list. We need to write a base case to stop the madness. If length of nums equals 0, return 0. The base case of a recursive function is the part of the function that does not call itself. Assignment. Doc can automatically generate various layouts for a page. There are a lot of possible layouts, so we need a factorial function to calculate the total number of possible layouts. Complete the factorial r function. It should recursively calculate the factorial of a number. Info, a factorial is the product of all positive integers less than or equal to the number. Less than or equal to, or equal to, yes. For example, 5 factorial, read 5 factorial is 5 times 4 times 3 times 2 times 1, which is 120. Tips. Let's write the base case first. And I'm curious what they say for tips. What is a small problem you can solve first? Two, how can you go from the first value of x to the next value of all the way down to the last value of x? 3, what's the base case that should stop the recursion? 4, since 0 factorial is an empty product, what should an input of 0 return? Somewhere in my memory, 0 factorial is 1. I was going to use 1 as the base case, but this is nudging me to use 0 as the base case. So let's do that. If x equals 0, return 1. Else, I don't need to write the else, but I want to. Else, return, we'll take x, and we'll multiply it by a factorial r of x minus 1. If only we knew the value of 4 factorial, then we could get 5 factorial by multiplying it by 5. Okay, let's run that. Looks good. Let's submit it. More XKCD. Okay. Recursion review. Your party enters the tavern. I gather everyone around a table. I have the elves start whittling dice and get out some parchment for character sheets. Hey, no recursing. They're about to play D&D inside of D&D. Fun. XKCD. I hate explaining jokes. It's the easiest way to make something not funny. But in case you don't get the comic, the joke is that the characters within the Dungeons and Dragons game are also playing their own Dungeons and Dragons game. Maybe their characters' game of D&D also has characters playing D&D, and so on recursively forever. But taking longer and longer, of course, at each level. Another example. Print, or define. Example, define print characters, word, and I. If I equals word, return, no. If I equals length of word, return, that makes sense. Return none. Not empty string? Moving on. Print. Oh, because we're printing, we're not returning. I would like it better if it was returning, but okay. Print word at I. Print characters of word, comma, I plus 1. Print hello at 0. So it prints the character at 0, then it prints the character at 1, and so on. Not a pure function because we're printing. What happens if a recursive function has no base case? It's no longer considered recursive, or it will keep calling itself forever, resulting in an infinite loop. Yep. Or Alan Turing comes back from the dead to haunt the author. Sure. Infinite loop. What is printed if I call print characters elephant 3? It starts at 3, which is 0, 1, 2, 3, PHANT, all on new lines, but I guess we don't have room for that here, so here we go. 4. Zip map. Let's practice another simple recursive function. You may not understand recursion just yet, but by following the instructions, you will begin to grasp the fundamentals. Assignment. Within doc2doc, we need to map certain properties from one document to properties of another document. Complete the recursive zip map function. It takes toList as input and returns a dictionary, where the first list provides the keys and the second list provides the values. Example usage, zipped equals zip map of list of movie names and list of numbers, which may be ratings. Print zipped comments. Avatar The Last Airbender 9.9, Avatar in Papyrus font 6.1, The Last Airbender live action 2.1. Oh, maybe for it's just we're using recursion to iterate through the dictionary. Is that what we're doing? Here's the pseudocode. If either the keys or values list is empty, return an empty dictionary in the base case. This takes care of the if condition. I don't know how I want to write the condition yet, so I'll just say condition return dict. Let's use this syntax. Oops. Would that do an empty dictionary or a set? We'll just use this syntax. Recursively call zip map on all but the first element from keys and values. Okay, it is for looping. Else we're going to call zip map. I'm indenting extra to remind myself that I might want to fill something in before that. Recursively call zip map on all but the first elements from keys and values. Oh, and zip map takes 2. Okay, sure. Keys from element 1 onward and values from element 1 onward. Okay, and we have the keys and values list, so now I know how to write this condition. If, oh, not if. What happens if you write if twice? Probably a syntax error. If length of keys, if length of keys equals 0, or length of values equals 0. If either of those is true, we return the empty dict. Recursively call zipmap on all but the first element for keys and values. And add the first element of keys to the resulting dictionary and set its value to the first element in values. To the resulting dictionary. Okay, got it. So we can say that D equals that. And then we do something with D. We add to it dictionary at key of keys list at position 0 is equal to list values at position 0. So we get D from the recursive call, we update D, and we return D. That should do it. Looks good. That's an interesting one. Let's save that aside just for interesting later use. Vim zip map .py. Okay. Consider the following function. Assume n is a non-negative integer. My favorite kind of integer. Define countdown n. Print n, side effect. If n equals 0, return, but it's a countdown, so okay, makes sense. Else, call countdown on n minus 1. Yeah, if n was a negative integer, we would have problems. Okay, but n is a non-negative integer, like 1 or 5 or whatever. Which line contains the base case? That'll be a conditional. If n equals 0. 6. Which line has the recursive call? Countdown n minus 1, calling itself. Right there. What would happen if we swapped countdown n minus 1 with countdown n for n? What? Oh. For n greater than 0? I think the formatting is not doing me favors. What if we swapped countdown n minus 1 with countdown of n for n greater than 0? Oh, I understand it now. They have to put that caveat in there because if we call countdown of 0, it doesn't matter what's on this line because the base case will return nothing. Okay. The answer is it'll just keep calling itself at a non-zero integer, and we have an infinite recursive loop. Bam. Okay. 8. Nested sum. Recursion is hard for all new developers. If you're struggling, that's okay. Take your time. That's why we're doing a few extra practice problems. Assignment. In doc-to-doc, users can process files or entire directories. We need to know the total size of those files and directories measured in bytes. Due to the nested nature of directories, we represent a root directory as a list of lists. Potentially lists of lists of lists of lists, right? Each list represents a directory, and each number represents the size of a file in that directory. For example, here's a directory that contains 2 files with root level, then a nested directory with its own 2 files. Root equals start list 1, 2, start list 3, 4, end list, end list. Print some nested list of root. Here's a more complex example. We have root, scripts, characters, seasons, and season 1 and season... Season 1 is a directory. Season 2 is just a notes file.txt. That seems incomplete, but it works for the example, which would be represented as root equals start list 5, start list 6, 7, end list, start list, oh yeah, we have the bytes numbers up here, start list 8, 9, end list 10, end list, end list. Print some nested loops, some nested list of root. Complete the some nested list function. It takes a nested list of integers as input and should return the total size of all files in the list. It's a recursive function. Here's some pseudocode to help get you started. Create an integer variable to keep track of the total size. I assume that happens in the base case. Maybe that happens at every level. For each item in the list, use a loop here. That you don't want me to. Oh man, now I want to write a recursive strategy to loop over the list. But okay, we can use the loop here. Oh, this is cute. LST for list, sure. I want to say for ls in list, but let's say let's be generic and say for item, ITM because style in LST. If type of ITM is LST, let me do something. If the item is a list, use a recursive call to some nested list to get the size of that list. Add that size to the total size. Is total a reserved name in Python? Let's check. No, it's not. Okay. So we can use total. And we crank that up by the result of calling some nested list on item, which we have determined is a list. Okay, backing up, if the item is an integer, I don't know why I didn't do that already. If type of item, wait, should I be saying type item is list or item is list? Let's check that. If I call type of t, I get class list. If I ask t, I don't think you call type of t. Class type. Oh yeah, I made a mistake. Huh. Type of item would never be list. It would always be type. But if I write a conditional for t is list, huh. Do I not understand how to do types in Python? Dang. Well, what if I do type of t equals lst? Wait, is it L? And if I try type of 5 equals list, we get false. Okay. Ugh. Also, I typed is LST, which is wrong on another level. Great. If it's an int, we can take total plus equals ITM. This is elegant, this way of typing and types. Return the total size when you're done iterating. Yeah, we need to remember to return. total is the thing that we return. Let's try that. I can control enter it. Oh, mistake. Ah, yeah. Might need a colon here for syntax purposes. Looks good. Control shift to submit. You've earned, oh, pardon the mic bump. You've earned a daily quest chest. Open chest. We've got 12 gems. Oh, I like all those spanglies. 12 gems, 1 armor, 2 seer stones. Tips. You can use loops with recursion. I'll read this. You can use loops with recursion. While functional programming avoids loops, recursion can be used outside functional programming. Oh, because we're talking about recursion here. Sure. You can use the built-in isInstance function to check if an item is an integer or a list. Oh, that's how they encourage me to do it. Well, let's do it that way. If isInstance, if the is an instance, we want to know is item an instance of int. That seems cleaner than what I had. If is instance item of a list. List list is a reserved keyword in Python, which is why they chose a different name for the argument here. If we run that, I missed a colon again. Come on. Okay. That works. I like that better. Recursion is so dang useful with tree-like structures because we don't always know how deep they're nested. Stop and think about how you would write nested loops to traverse over a tree of arbitrary depth. It's not easy, is it? I saw a post about, I don't remember what it was. For item in tree, for nest. Okay, this will be fun. When does it end? I sort of want to generate a humorous, much wider example of this. For item in tree, for nested item in item, for nested item in nested item, for nested item in nested item. When does it end? I most often use recursion on tree-like problems, file systems, nested dictionaries, etc. If I'm just iterating over a one-dimensional list and then a loop gasp is typically simpler, even if it's not as pure in the academic sense. Remember, the rules of functional programming are just philosophies to help you write better code, but it's not always the right tool for the job. The same goes for any programming paradigm. What makes it hard to loop over a tree? You don't know the depth of the tree, number of nested levels. That seems like the answer, but let's continue reading. You don't know the breadth of the tree, number of items at each level. I guess that also contributes. The trees have too many items in the initial list. That doesn't seem relevant. Loops are hard for my smooth brain. Okay, fun. The depth of the tree is what makes it difficult. 10. Imperative loops are allowed in purely functional code. Well, false. But do we always need to write purely functional code? Loops are often used by good programmers even though they break the academic rules of functional programming. True. 12. Recursion on a tree. How many are there in this? Up to 15. Recursion is often used in tree-like structures. For example, nested dictionaries, file systems, HTML documents, JSON objects. That's because trees can have an unknown depth. It's hard to write a series of loops because you don't know how many levels deep the tree goes. For entry I in dictionary, if entry I is dir, for entry j in entry I, if entry j is dir, that's so ugly, for entry k in entry j, and so on. Assignment. You're responsible for a module in Doc that can scan a file system represented in our code as nested dictionaries and create a list of the file names. Complete the recursive list files function. It accepts two arguments: parent directory, a dictionary of dictionaries, sure, representing the current directory. A child directory's value is a dictionary and a file's value is none. Let me read that again. A child dictionary's value is a dictionary and a file's value is none. Do they give us examples below? Example parent directory. Here we go. So this is the parent directory. It has its documents. In that we have a dictionary, proposal.docx value none, so that's a file. Receipts, and its value is another dictionary for January. Okay, this is making sense to me now. Current file path. Oh, that's interesting. A string representing the current path, e.g. dir1, dir2, filename.txt. It should return a list of all file paths in the parent directory. I'll call it file paths. Create an empty list to store the file paths. That's what I was going to call file paths. Use a for loop for to iterate through the keys of the parent directory dictionary. For. Do I want to call it key? Sure. In parent directory dot keys. Use the key to create a new file path by concatenating a slash, 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 and the key to the end of the current file path. So we have current file path plus slash plus key. Very good. Now what are we going to do with that? Let's call it new file path equals that. Then we do if parent directory at value key equals none. The key is a file name. Dot append the new file path to the list of file paths. File paths dot append new file path. Otherwise, the value is a child directory dictionary. Let's use a variable for useful context. Else child directory equals parent directory at value key. Recursively call list files on child directory with the child directory dictionary and the new file path. Use the dot extend to add the result of the recursive call to the list of file paths. File paths dot extend the result of the recursive call. Return the list of file paths. We have that here, return file paths. Example parent directory, yeah, I was reading that before. Resulting list of file paths, documents, and proposal and receipts and so on. Let's just run it. Failed! Name, file path, okay. File paths. It's not defined. Where did I do that? There it is. Still not right. because, okay, it would have given the wrong file path there. And the new file path. I missed that. File paths.extend, list files of child directory. Where do I get the new file path? Oh, okay. Yeah, they told me what to do. I just didn't do it. Child directory, comma, new file path. Now run. Passed. Okay, let's go. Let's do another buy and activate potion. Neat. Dangers of recursion. Recursion is great because it's simple and elegant. Simple, not equal easy. It's often the most straightforward way to solve a problem. Stack overflow. Each function call requires a bit of memory. So, if you recurse too deeply, you can run out of stack memory, which will crash your program. This is what the famous website is named after. Stack memory. Stack-based memory allocation. Let's echo read about stack memory into to-do.text using the double arrow in case I had already made a to-do.text. 2. If you don't have a solid base case, you could end up in an infinite loop, which will likely lead to a stack overflow. 3. Recursion, especially in a language like Python, is often slower than a for loop because each function call requires some memory. Tail call optimization can help with this, but Python doesn't support it. I remember I was starting to learn about that somewhere. Which is typically more performant in Python, a regular old for loop. You've earned a sharpshooter chest. Neat. Open chest. 5 gems and 1 baked salmon. I kind of want to use a baked salmon just because I can. Okay, 13, 14. Recursion practice. Recursion practice. In .doc, we have a search function to find the longest word in a document. Assignment. Complete the find longest word function without a loop. Without a loop, sure. It accepts string inputs, document, and an optional longest word, which is the current longest word and defaults to an empty string. Check if the first word is longer than the current longest word. If length of document is a string, so we can split on spaces to get a list. And take the first one, which is going to be a string, and then we take the length of that string. If that's longer than length of longest word, then we do something. Then recur for the rest of the document to find longest word. Words with equal length to longest word should be skipped. Yeah, that's how I wrote it. Find longest word of. Oh. Recur the rest. It would be more helpful to. You can now accept a quest. I'm not going to do that now. Mark as red. Word list equals document dot split, and replace document with that with word list there. And now we'll make a new document equals word list from 1 to the end. And I'd like to do it dot join, but that's not how Python rolls here. We have to do space dot join space.join word list 1, and now we can find it on try it on new document with longest word equal to you know what? Let's refactor this with a current word variable. Now we can say if length of current word and call it with current word. And is this meant to return something? Is it? Assume that a word means a series of consecutive non-whitespace characters. For example, find longest word, how are you, should return the string you. Yeah, that fits with what I'm doing. Review the provided tests in main.py to the expected behavior, including edge cases. Sure. Oh, this is useful. You can use dot split with max split of 1. That will split a string into a list of first word, comma, rest of string. Helpful. Let's refactor according to that. And we can use tuple on, or I guess it's list unpacking. First word, comma, rest string equals document dot split. Oh, I forgot to split on a space. And now I can call max split equals 1. That's nice. You're no longer using current word. If length of first word greater than length of longest word, use first word. And new document is just rest of string. And I'm thinking we're going to return this. Let's see about the expected behavior in main.py. Run cases. Either that wallpaper goes or I do. Okay, wallpaper. Then I die happy, happy, et tu brute, brute. May have to think about these. What happens if it's an empty string? What if we split on space in an empty string? Let's just test that. Empty string dot split space. That is interesting. We get a list with an empty string, which means it will fail here. Watch, if I do first, comma, rest equals list with an empty string, there will be problems. Not enough values to unpack. Also, I want to look at the other edge case. Space.split on space. It should give us 2 empty strings. What are we supposed to do with... I'm starting to get tired. I think this will be the only chapter I do tonight. So it seems like the two things we need to be careful of are either a document that is empty or something that either starts or ends with a space. Because if we do quote space word quote, not rod, and it doesn't matter here, but not rod, not split space, we end up with an, and if it ends with a space, we end up with an empty thing there. We can use empty string as a base case of sorts. If length of document 0, just return longest word, then let's make a split list with the document.split. And now we handle the case where, I think the only case where is there, let me think. Is there any way to get a list of length 1 other than with the empty string? I don't think so. Well, yeah, there is. If we just have word dot quote word dot split on space, we still get word. So, yeah. Even if the length of the document is not 0, the length of the list can still be 1. If length of split list equals 1, what could it ever be 0? No, it couldn't be. I'm going to write something that may be a duplicate, but we'll possibly deduplicate it later. Because I need to check if I'm getting tired here. You could just where do we get first word will always be fine because it comes from the 0 index of unless it's an empty list, but we already determined it can't be an empty list. But it can be a list with just word. Let's do it this way. Rest of string, we'll just initialize it as an empty string here. Otherwise, we can say that it's the one position of the rest of the list. Now, I don't like that we're also what's the else here? I thought this was easy, but I keep running into more details that I hadn't thought about. Oh, we can just use longest word. Pass it along. Okay. Find longest word with rest of string, longest word. Whew. I think I'm ready to run this now. I hope I didn't make any mistakes. I made mistakes. Return? No. Return. First word is not defined. I changed my mind about where to put things. We need to define the first word equals split list at 0. We've determined that we can always do that. And let's think through what'll happen in these test cases. We input an empty string. And the input 1. So we find longest word of empty string. If length of document is 0, return longest word, which will end up being the default, which is 0. Okay, that works there. Now if the input is a string with a single space, then this doesn't happen. We do split list. Max split is 1. In fact, the number is supposed to be 0. No. Anyway. I think it's fine to submit. Yep, got him. Recursion practice. In doc-to-doc, we might have documents nested inside other documents, forming a kind of tree. You know how crazy .docx files can get. Sure. Anyways, we want to find out how deeply nested a given document is. Assignment. Complete the count nested levels function. It takes a dictionary of nested documents, the target document ID, and the current level of the document. Okay. Loop over document IDs in the nested documents dictionary. A dictionary of nested documents. So for something in nested documents.keys, and I'm assuming those are strings. Oh, they're document IDs. Okay. Document underscore document ID in that. If the ID matches the target document ID, then we do something. Return its level, that's all. Okay. If the target document ID is not fine, so if we make it out here, recursively call count nested levels on the current document ID loop over document IDs in the nested documents directory. If the current document ID matches target, if the current document ID matches the target document ID, return its level of nesting. Return level, yes. If the target document ID is not found, is this for each document ID or at the end of considering all document IDs? Recursively call count nested levels on the current document ID and increment the level. If the recursive call found the target document IDs, return it. If the target document ID doesn't exist, the function should return -1. Maybe the example will help. Example: in this extension, the document with ID 3 is nested 2 levels deep. Document 2 is nested 1 level deep. Okay, that's 1 level deep. That's 2 levels deep. So if we come to a document ID that is 3, we return 3. On the current document ID implies that this needs to go in here. And we do it level +1 because we're inside of this for loop. If the recursive call found the target document ID's level, return it. So if this whole thing, not equal -1, oops. Then we can say if the recur count is not equal to -1, return the recur count. I think if we make it here, then we need to return -1. Let's control enter this for run. Oof. Oh yeah, well we don't call this on document ID. We call this on nested documents at document ID. But we still failed. Now what? Expected for actual 1. How did I give it a 1? Oh wait, that's the... What am I supposed to count nested levels? I'm supposed to be returning the count. Somehow level needs to come into it. Where did 1 come from? Where did I get 1? What? Oh, return level. One, two, three. Let's see on this first example. 1, 2, 3. We're looking for 2, 3, 4, 5, 6, 8, 9, 10. So if we find it, we return the level. If we don't find it, we ask the recursive call. Oh, wait. Yeah, I fed that wrong. We need to pass along the target document ID and then the level plus 1. Try it now. That's better. Let's just do it. Yes, got him. Okay, I'm probably not going to do another chapter tonight. There are quite a few more chapters in this. I do have XP gain active, but meh. Let's take a peek at the next one. I like the idea of function transformations, but I'm not sure I feel up for it to continue learning and streaming tonight. Yeah, let's call this a stream. Probably tomorrow I'll continue on with chapter 5. So, let's exit from this Python REPL and echo thanks for watching. All right, thanks for watching.